While you're using your computer, everything is stored in memory. The video you're watching right now, or your photos are stored in memory while you're looking at them. Everything you do is stored in memory while you're using it. This is RAM, computer memory. This is where everything is stored. But this is just electronics, made up of electronic components and wires. So how can we use electricity to represent all of our videos, all of our photos, all of our data? And we can think about a single piece of computer memory as looking something like this. An electronic current going round and round, being preserved on the wire. And if you can think about the voltage on this wire as being high or low, then we can imagine a high voltage as representing a 1, a low voltage as representing a 0. And this is the golden abstraction of computing, where we can begin to represent binary numbers using electricity. We can read whether the value is high or low by attaching a light bulb. If the light bulb comes on, then we know the voltage is high. And if the light bulb doesn't go on, the voltage is low. So when we have a high voltage, the light bulb turns on and we have a 1. When we have a low voltage, the light bulb is off, representing a 0. We are representing a single bit here. Bit is a portmanteau of binary and digit. And portmanteau is a word I googled which means mix two words together. Now we know how we represent a single bit using electricity, using voltage high and voltage low to represent 1 and 0. So now we can hide the wire and just think about the light bulb for a moment. If the light bulb is off, we have a 0, and if it is on, we're representing a 1. But we want to represent more than just 1 or 0 if we want to see videos and photos and everything else we want to do on our computer. In order to do that, we need more light bulbs, more bits. By grouping 8 light bulbs together here, 8 bits of memory, we've created a byte. A byte is just 8 bits of memory together. And using 8 bits, we can represent far more than a 1 or a 0. By thinking about all of these bits as digits of a much larger number, we can represent any number between 0 and 255. Memory today is expressed in terms of gigabytes. This chip has 4 gigabytes of memory on it. A gigabyte is 1 billion bytes. That's 1 billion rows of 8 light bulbs. So we can think about memory as a long, continuous, one-dimensional array of these light bulbs, of these bytes, representing a binary number, 0 to 255. But with so many bytes, how do we find them? Well, we index them, just like an array. Starting from 0, we count all the way up to the billions and billions of bytes that you could have in your laptop. And we call this index an address. If you've ever worked with a language which has pointers, then all a pointer is a number referring to the address or index of the byte you want to read. The way this chip works is you tell it which byte you want to read and it returns the value at that address. And that's memory. One long continuous array of 8-bit bytes that we can think about as rows of light bulbs representing the numbers 0 to 255. But how do we represent more complex things than the numbers 0 to 255? Well, that's something we're going to look at in the next video, so look out for that. Should be out in the next few days. Thanks for watching. This has been 54M, and I'll see you soon.